Today, we're going to pull back the curtain on something you use every single day but probably never think about. We're going on a journey to uncover the hidden instruction manual for the entire internet. So think about it for a second. It's an action you do dozens, maybe even hundreds of times a day. You type a web address, hit enter, and poof, a full, secure web page appears, almost instantly. It feels like magic, right? But it's not. It's an incredibly fast, perfectly choreographed dance of technology. So what really happens in that split second between your click and the content lighting up your screen? That simple request you just made, it didn't just go straight to the website. No, it took a trip down and then back up. A 7-layer communication stack. And believe it or not, pretty much every single piece of data flying around the internet follows this exact same path. To understand this journey, you need a map. And our map for today is the OSI model. Okay, so the Open Systems Interconnection Model, or OSI for short, is basically the universal rulebook for network communication. It takes this ridiculously complex task of sending data from point A to point B and breaks it down into 7 distinct, manageable stages. Without this shared set of rules, the internet we know just wouldn't work. It's the reason an iPhone in Australia can talk flawlessly to a server in Germany. And here they are, all 7 layers, from top to bottom. We're going to follow your website request as it travels down this stack, starting right at the top, where you are at the application layer, and going all the way down to the physical wires and radio waves. The best way to think about this whole process is like you're preparing a package for international shipping. At each step, each layer adds a new label or another layer of wrapping, getting it ready for the next part of its journey. So let's start our journey right where you did, at the very top of the stack, layer 7. The application layer is the one that we, as users, actually interact with. Well, sort of. It's not the web browser itself, but it's the protocols that the browser uses to talk to the network. In our shipping analogy, this is the actual item you want to send. So, in our example, when you typed in that web address, your browser generated an HTTP request. That request is the actual data that kicks this whole thing off. It's a little message that basically says, "Hey server, can you please send me the files for this website?" Okay, we have our data. Now we drop down one layer to get it ready for travel. The presentation layer is kind of like the network's translator and security guard, all rolled into one. Its job is to make sure the data is in a format that the other computer can understand. And, super importantly, this is where encryption happens. Think of it as putting our item into a secure, locked box. You know that little padlock icon you see in your browser's address bar? This layer is where that security starts. It takes our simple HTTP request and gets it ready to be encrypted, scrambling it so that nobody snooping on the line can read it. That's right, Transport Layer Security, or TLS, what we used to call SSL. That's the magic that happens right here. It's what turns HTTP into the secure HTTPS, locking our data package up tight. Our package is locked and formatted. Now we need to actually establish the connection. The session layer is the conversation manager. Its job is to open a connection, keep that connection stable while data is being sent, and then close it down neatly when everything's done. It's like calling ahead to make sure the recipient is home and ready to receive your package. This layer makes sure your computer and the web server can maintain a steady dialogue. And if you've ever logged into a website, you can thank the session layer for helping manage that state so you don't have to put your password in on every single page. All right. The connection is open, but how do we make sure our data actually gets there reliably? Welcome to the transport layer. This layer is a huge deal. It takes our big chunk of data and breaks it into smaller pieces, called segments. Then it makes sure they all arrive at the other end correctly and in the right order. This is like putting our locked box into a sturdy shipping box and slapping a tracking number on it. For web browsing, this layer uses a protocol called TCP, and it adds a really important label, the port number. Now, think of an IP address as the street address of a giant apartment building. The port number, like 443 for HTTPS, is the specific apartment number. It tells the server exactly which service our data is trying to reach. And this right here is a fantastic aha moment. You ever wonder why your video call might glitch for a second, but a web page always seems to load perfectly? That's layer 4 at work. For a web page, you have to use TCP because every single piece has to get there, guaranteed. It's like registered mail. But for video streaming or online gaming, you often use UDP. It's way faster, but some packets might get dropped. It's like sending a postcard. Speed is more important than perfect delivery. Okay, our package is in its shipping box, it's got a tracking number, it's got an apartment number, now it needs the main street address.
The network layer is the global postal service of the internet. Its main job is to figure out the best possible path for the data to take across this massive, tangled web of networks. And it does this using what we all know as IP addresses.
So at this stage, our data segment gets another wrapper, and now it officially becomes a packet. And stamped right on the outside is the destination IP address, the unique, global address of the web server we're trying to reach.
We have the global address, but how do we get the package from our laptop to our Wi-Fi router? From our house to the local post office. Well, that's the job of the data link layer. This layer handles the short, hop-by-hop journey on your local network. It doesn't care about the final destination halfway across the world. It only cares about getting the package to the very next stop, which is probably your router. And for this, it uses physical addresses called MAC addresses.
So here, our packet gets one more wrapper, and now it becomes a frame. This new wrapper has the local address of your router. Think of it like a sticky note just for the local mail carrier. But here's the really cool part. Once it reaches your router, that sticky note is ripped off, and a new one is put on for the next single hop. This process of rewrapping happens at every single stop across the internet.
We've reached the bottom. Our package is fully wrapped, fully addressed, and ready to go. It's time to actually send this thing. The physical layer is, well, it's exactly what it sounds like. It's the physical stuff. The copper cables, the fiber optics, the radio waves for your Wi-Fi. It takes our beautifully packaged digital frame and turns it into actual physical signals. This is where the ones and zeros finally stop being abstract concepts and become real electrical pulses in a wire or flashes of light in a fiber optic cable. The data is no longer just data. It's physically traveling across the world at nearly the speed of light. And just like that, our request is sent. It zips across the internet, finds the server, and the server gets the message. But what happens then? The server does the exact same thing we just walked through, but in reverse. It receives the physical signal at layer 1, unwraps the local address at layer 2, reads the IP address at layer 3, and so on, unwrapping the package layer by layer until it gets to the original request at layer 7. Then, it grabs the web page content and sends it right back to you, following the same 7-layer packaging process all over again. Okay, so we just followed our data on a pretty incredible journey. But this isn't just some abstract technical lesson. You might be wondering, why does this 7-layer model actually matter in the real world? The absolute genius of this layered approach is standardization. It means a company that makes amazing Wi-Fi cards can focus entirely on layers 1 and 2 without needing to know a single thing about how a web browser works at layer 7. It's also an incredible map for troubleshooting. If you can't get online, you can diagnose the problem layer by layer. Is the cable unplugged? That's a layer 1 problem. Can you get to some websites but not others? That could point to a layer 3 routing issue. It gives us a logical blueprint for both building and fixing the internet. The OSI model shows us that the internet isn't some magical, unknowable cloud. It's a stack of agreements, a tower of trust, built on rules that let everything work together almost perfectly. So the next time you hit enter, just for a second, remember that incredible, invisible journey from a simple click down 7 layers into a pulse of light, across the entire world, and all the way back again, all in the blink of an eye.